Hello, can everyone see my screen? All right, great. Let's get started. So first thing I would like you to do is go to the link, the code link specifically, in the description of this video. It'll take you here. And the first thing I would like you to do is set up a CodeSpace machine. That'll make it easy for us to run it. So you click on CodeSpaces, and create CodeSpaces on main. It'll take a while to set up, so let's give that a few minutes. In the meantime, let's go over how this workshop is going to be structured. So this workshop is going to be based on a Jupyter notebook. The idea here, or the objective here, is to help you understand the different parts of a data project, so you can go ahead and build your own using your own data and using your own data tools that you prefer. And the main outcome is for you to understand how to build pipelines following industry standard patterns. You can use the same pattern with dbt, with Spark, Snowflake, Pandas. In this exercise, we will use Polars. This will take a while to set up, so let's go ahead and look at the introduction. So this workshop is meant for people who are having difficulty setting up their own data project, whether it be for your data portfolio or for work. And I do want to specify that this project is meant for, the patterns in this project is meant for like really complex systems. If your data pipelines, if you only have like 4 or 5 data pipelines, you don't really need to follow all these steps. You can just skip to just creating a script. Let's see if this is started. All right, so it seems like the requirements have been loaded. So VS Code or CodeSpaces will automatically install the requirements. So let's go ahead and open our IPython notebook, which is Jupyter Notebook. And let's go ahead and run this. Again, this, make sure to set it up. And when you set it up, you will be able to run all the steps here. All right, so the first part is kind of understanding an overview of the parts of a data project, right? So the key part is the requirements. You need to start here. You need to understand what the requirements are before you even think about designing anything. So that is the initial step. You probably should not be designing anything without solidifying your requirements. It might be okay even if your columns are not fully defined, but it's critical that at least the base patterns are there. So for example, you need to know the grain of certain tables. You need to know what output the stakeholders are looking for. So that's the first step. And then we'll go over multi-hop architecture. So typically companies use dbt style if they're using dbt, or medallion if they're using Spark. And within that, people typically use a data model technique. So it's usually Kimball, but sometimes people use Data Vault or Activity Schema as well. But we will see Kimball data model in this workshop. Once you have the design, you decide how to orchestrate it. A popular tool is Airflow, which is what we'll see later. And then you decide how to process your data. So it can be Spark, it could be Snowflake, it could be Python, it could be Pandas, it could be Postgres database. In this example, we'll use Polars, but you can use any system to process your data. And you'll have some data tools like Great Expectations, Python request library to interact with different systems or to run data quality checks. And finally, the virtual containers, so things like Docker and how it's run on the cloud. I'm going to stop here before going forward. Any questions with this? Okay, I guess there are no questions. DBT, okay, DBT, it's not actually a data processor. DBT is a data lineage tool. So when you write SQL, DBT, all it does is it orders the SQL in the order that you have defined, and it executes it in a data processing system. So it will execute it in Snowflake, it will execute it in Postgres, it can execute it in Spark SQL, but it's not actually running the data processing. It's controlling the flow. So it's saying run this model first and then this and then that. So it's not really processing the data, it's a way of organizing your data flow. Does that make sense, Narendra? So I'll call it an orchestrator, similar to Airflow, which gives you much more flexibility on how you define these different tasks. So we will build using Docker container, and the next step we will deploy to AWS. Yeah, there are links in the workshop to go over design patterns. Yes, it is important to write clean code. All right, so let's keep going. So the first step is defining the requirements. So even before we talk to our stakeholders about requirements, we really need to understand the data that we're working with. So what does this mean? That means understanding our upstream data sets. Where is the data coming from? What business process and what application systems create this data? Is it created by a human, or is it created by an automated system? Is it created by some sort of Excel uploaded into some place? So you have to know that very clearly. How frequently is it updated? Are there issues with the data set? So these are really critical. And more often than not, this is the hardest part, especially in larger companies, because the upstream data sets are really sometimes really complex. So you need to really understand the upstream data sets. So we are going to use something called a TPCH database, which is like a data set used by all the databases to measure their analytical query performance. So when you hear benchmarking, it's usually on TPCH database. It represents a car parts seller database. So you'll have orders, people can place orders, and each order will have can have multiple items. You have customers and suppliers who supply those orders. And you have information like nation and region for customers and suppliers. And you also have the different types of parts and what their sizes, what their retail prices, etc. So in this case, our input is quite simple. In real life, it's not often the case, and upstream teams have their own vision of data model, which doesn't always align with the standard normalized data model we expect in OLTP or transactional databases. And the same with like any other sources. So you need to really understand the input data set before even thinking about what you can do with it. All right, so first step, we have to create some input data. There's a script here, so if you go ahead and press this execute cell and click on Python, oh, sorry, not Jupyter, let's stop this. All right, let me stop this. I have to reopen it. So open this. Let's go and let's run it in Python. It's running. All right, while that's running, let's see what it does. It basically creates our input data set, puts it in a DuckDB database, which we consider our input source. One of the main things you should do before you start collecting requirements is to identify the grain of the tables. The grain meaning what does an individual row in the input table mean, and the business process that generates the data. So what this means is it generated by an automated system, or is it generated by some sort of manual process? So that will help you define how your data is going to flow. All right, I have a quick exercise, maybe take 2 to 3 minutes. Looking at this relationship diagram, could you please say what is the relationship between orders table and customer table? Like, what is the relationship when you go from orders to customer? Is it one to many, many to one, many to many, or one to one? I'll give like 3 minutes. It should be relatively straightforward, kind of thinking about how orders and customers work in like standard sales systems. You can let me know in the chat as well if you know the answer, or if you can't complete it right now, that's totally fine. You can complete it in your own time. One to many, okay. So the answers are in this answer setup thing. So the answer is one to one, because one order is usually placed by one customer. An order cannot be placed by multiple customers. One order is placed by one customer, so it's one to one. All right. I'll leave this for you to do on your own time. Again, the answers are in this answer setup data project Python notebook. Should be this kind of same logic here as well. All right. So now that you have an understanding of what the input data set is looking like, the next step is to clearly define what the stakeholders want. That's right, Viresh, but the relationship is from orders to customer. So one order can be only placed by one customer. You're talking about the other way. Customer to orders is what you're talking about. So there's a direction, right? Orders to customer, one order placed by one customer. And when you think about customer to order, one customer can place many orders. So it's a directional relationship. All right, so let's go on to the next one, defining what the output is going to look like. This is very critical, and oftentimes this will keep changing over time, but what you have to really nail down is the grain of the data set that they're looking for. So what that means is, what does one row in the data set represent? So here we are calculating some metrics per customer. So you can see for every customer, min, max, average, order values, and number of average number of items per order. So even though you might not know all the metrics, by metrics I mean the computational metrics, numerical metrics like min, max, average, you know the grain. So that is critical, because once you have the grain locked down, you can add or remove columns or change columns. But the grain is critical, because once you define that, it's going to be used by a lot of downstream sources, and you can change it, but you typically want to keep the grain the same so that downstream systems are not impacted. All right, let's look at a simple query on how we can do this. This is a very simple output data set. What we need is customer level metrics, we need order values, and we need items per order. So let's think about this. Before writing any SQL query, let's think about this. We have customer data, we have order data, and we have item level data in line item table. So we have a customer table, orders table, and line item table. Before we write SQL, let's think about it step by step. We need min, max, average of order values at a customer level, and we need average number of items per order per customer. So first of all, what are the tables you think that we need to compute this output data set? Or what are the input sources that you think we need? Maybe I'll give like 2 minutes. Please feel free to type in the chat. Yep, that's correct, Venkatesh. You need orders, items, and customers. Customers is the dimension, or we'll go over dimensions later, but basically that's like a business entity. Orders and items are facts. Again, we'll go over that later. What that means is an event that happens in real life, and we just compute the metrics. This is a simple query where basically I compute line item to order level, and then joining customers with orders, and then grouping by the customer key and name. So orders, we saw one order can join with one customer. Or sorry, in this case, it's from customer to order. So sorry, one customer can join to multiple orders. So that's what we're doing here with the customer key. And then this table already has data at orders level. We have order metrics. So you can see like order key, total price, customer key. These are all order level metrics. And we had also computed number of items per order. So we are joining that as well. So we have all the metrics required in customer order CTE. And then we join it with customers and aggregate it to the required level, which is customer name and ID. If you're not familiar with CTE, I had another YouTube live that goes over what CTEs are, so I recommend you check that out. Now, we have the output. It's pretty straightforward. So let's go ahead and run it. Did that run already? Okay, that was fast. We have the output. So this is the output, right? Now you might be wondering, why do we need to do anything more? We have the output. We have the data here, we have the code here, and you might be right in thinking that, right? Because you don't want to do more work than necessary. But this is a very simple example, and we are only considering one use case. However, in real life, there will be multiple such requirements. There will be like requirement for customer level metrics, customer day level metrics, supplier level metrics, product level metrics. There will be so many requirements. So while we can do this and then have to do that the same for each requirement, it's better if we model our data and set it up in such a way that computing the required metrics are super easy. And that's what we are going to see next. We'll see in the next few sections. The other thing to define is also SLAs. It stands for service level agreement. In the service, it's a vague term, but typically in data pipelines, it means our data output, like what is our you can consider the output of a service as the data set that it produces. There are many agreements we can make, but the typical ones are data freshness and accuracy. Freshness means how recent is the data, and accuracy means does it confine to the defined data quality checks that we have defined. Freshness, it's easy to define. We can say, like, for example, here we can say like data should not be older than 12 hours. That means you need to ensure that your pipeline runs at least once within the 12 hours. Typically you want to run it multiple times just because if something fails, you can rerun it. And the next one is data accuracy. This is a very tricky metric because it's always changing, right? There's new data quality checks, you have to add that here. So when you start with data accuracy, you start with working with the stakeholders to define what that means to them. And then you eventually will add more or change stuff as you see fit. But the first, when you're building it from the ground, you want to have some sense of accuracy by working with the stakeholders. So let's say we talk to our stakeholders, end users, subject matter experts, whoever, and we define certain accuracy metrics. So the first one is pretty straightforward. The customer key has to be unique, meaning the data set is at a customer level. So each customer can only have one row and it cannot be null. And then the second one is a little bit tricky. The average metric, right? So we have average number of items per order, average order value. They should confine to 5% change run over run. So let's take a step back and think about this. What does this mean? This means if you're processing a snapshot of the input data every day, or let's say every hour, you want to make sure the data in this hour compared to the data in the previous hour does not differ by more than 5%. This is like a threshold check that's typically done for important numerical metrics. And this is kind of used as the default because people might not really know how a metric behaves. And this will ensure that you're not making any mistakes. And let's say if your revenue is 100 every day and suddenly it jumps to 1,000, obviously something is wrong, or it's Thanksgiving or something. Oops, sorry. So you want to make sure that the metrics kind of remain consistent. A more advanced version of this is called anomaly detection, where you can use standard deviation to identify the variations. But this is a good first step. So let's define that the average metrics should not vary by more than 5% between each runs. So there's a quick exercise. Again, the answer is in this answers notebook. Yeah, that's right. You want to check for data skewness. Yeah. The answer is in the answers notebook, but I'll give like 5 minutes for this. Look at the metrics we have for the required output. What other check can you think of for the output data set? So this is our output data set, right? We are checking the average metrics, both average number of items per order and average order value. We are also checking that the customer key has to be unique. What are the other checks that you can think of that you would like to run on this particular output data set? I'll give like 3 minutes. Please feel free to type in your answer in the chat. All right. Guess there are no takers, so I'll go ahead and give the answer. I would check the same variation for order values, so min and max, are they within the same range? Because if you suddenly get like a max order value that's like 10 times the normal, you want to check. That is true. Yep, that's right. Cross-table validation. I'm not 100% sure what you mean, Viresh. Those are good ones. Existing customer is there. Referential integrity check, which is cross-checking with the customer table. That's great. That makes sure that we are not missing any customer. That's great. Yep. Different price of. I assume by cross-table validation, Viresh, you mean that we want to check with another table, specifically the customer table, similar to the referential integrity check, would be my assumption of what you're saying. All right, let's keep going. It's already 1:20. All right, so typically the next step is identifying what tool you want to process the data, right? Typically, if you're working in a company, this is usually set up for you. You already have your choice of like Spark or Snowflake, etc. But if you're building your own project, I recommend starting with something simple. And you want to make sure that when you start, you want to start with something that can comfortably handle your data set. In our script, our data set is about 1 GB, so it's not that big of a data. So we'll choose Polars, but the same patterns and the same process that we'll see can be applied to Spark or Snowflake or Python, just native Python or DuckDB, whatever you want to use. Yeah, I see a lot of referential integrity checks. Yeah, that's right, Janelle. Sometimes the order might be large. That's why we have max and min. But if it's exceptionally large, let's say more than 10% or 20%, then we might want to flag that. We might not necessarily want to stop the pipeline. We might just want to raise a warning. So that's like different levels of data quality alerts, which we will see later. And you can also read it in these through these links. All right, for this exercise, we will use Polars. It's very similar to Spark and Pandas. We will use data frames. Should be relatively straightforward. All right, so let's take a step back and think about data flow architecture. Now we know what the input is. We know what the output is. What exactly the output metric should be, the grain should be. We know all that. Now, how do we go from input to output? In this case, it's pretty straightforward. You can just write a SQL query. But in real life, with multiple tables and multiple use cases, you typically want to separate concerns, so it makes it easy for you to develop and for the end user to use the data. So those are the key critical things. The end user should be able to use the data easily. They don't have to guess metric calculation. They don't have to do joins, a lot of joins. on their own. It's basically they can just do a select star. All right, so typically you have 3-hop architecture. It's in Medallion or Spark, it's called bronze, silver, gold. In DBT project structure, it's called source, stage, intermediate, and marts. So it's kind of the similar principle. So what happens is you have these sources. This could be an API source. This could be an upstream database source. It could be a flat file. It could be somewhere in your cloud storage. It doesn't matter. You have your source. You copy them into you dump them as is into a location called like raw or base, and then you do some transformations, level step by step, and those transformations result in bronze, silver, and gold. Those are the 3 steps we'll see. All right. So the first step is bronze. So as I said before, we get the data from input datasets and dump it as is, no changes, as is in a cloud storage or in a table, wherever it might be. We dump it in a location, and then we transform it to confine to our standards. So this in bronze layer, typically what people do is change the names to match the warehouse criteria and change the data types to match the warehouse convention. So let's see how that's done. We have all the input sources here from customer, orders, line item. Don't do select star. I'm just doing it for ease, but make sure you choose the columns you require. All we are doing is removing the first 2 characters from the column name, and this is because the first 2 characters would be would be something like this, right? The first 2 characters are C underscore, and all the tables have this naming convention. So we just use that, right? So that's what we are doing. We are removing the column names, and we are doing some renaming, just some simple renaming for our use case, just naming cust key to customer key for more deliberate. Again, this will depend a lot on your company, like what kind of standards they have. If you don't have standards, just use something from the internet. Just make sure you're sticking to it. It's better to have something than no standards. All right, so it should be relatively straightforward. Let's go ahead and run it. All right, so what we have done here is we have connected to our source system, which is DuckDB. Did some cleaning for customer, nation, region datasets, and that's about it. So I want to give like 5 minutes. So here we have cleaned customer data. I want you to take some time to clean the orders and line item data. So we already have pulled the orders and line item in orders df and line item df. I want you to take some time, let's say 5 minutes, to first of all remove the first 2 characters, so similar to this, and rename customer key and order key to customer underscore key and order underscore key respectively. So it'll be called, I think, yeah. So I would recommend looking at the data model, seeing what the customer key and order key are called in the order and line item table, and converting it into customer underscore key and order underscore key. I'll put like 5 minutes on the clock. Should be very similar to this one right here. Please let me know if you have any questions in the chat as well. ITfied, you can kind of actually just write the code and run it. Should be relatively straightforward. The idea is for you guys to kind of run it along with me, so it's easy. Kind of, you're most used to the code. again, if you can't complete, that's totally fine. We have answers in the answers Jupyter notebook, so it should be fine. Again, if you have any difficulties or questions, let me know in the chat. No, Doreen, changing grain basically means if you have a table that's, let's say, at line item level, like each item of an order, you can group by order key and change the grain to order level. That's what I mean by changing grain. Changing dimension is a type of data modeling that we can follow in the Silver layer. So changing grain is a process. It's basically changing what a row represents. So if you have, like, I don't know, customers, you can group by area to get like area grain metrics, right? That's changing grain from customers to like zip code maybe, right? Changing dimension is a different thing. It's a data modeling technique, which we will see in like the Silver layer. All right, I'm gonna assume you have some answers here, but basically this would be it. So what we are doing is, again, the same thing. We are removing the first two characters of column names, and then we are renaming cust key to customer key, order key to order underscore key. That's it. Let's run that. Should be fine. Great. So yeah, that's right, Viresh, but you should also remove the first two characters of the column names. The answers are, again, in the answer setup by Jupyter Notebook, so feel free to check that out. So now we have our bronze datasets. We have customer, we have orders, we have line item, and we have nation and region bronze dataset. The second step, or the second layer, is usually called Silver layer. And this is where companies do different things. Companies follow different data modeling patterns in this layer. The idea in this layer is to model your data in such a way that further analytics on top of that data is easy. So what does that mean? That means when you want to run group by, when you want to run large joins, this data model should facilitate that and make it easier. So that's what that means when we say getting the data ready for data analytics. When you say analytical query, it's basically a large group by filtering by some criteria. All right. Let's see. Okay, so we, again, coming back to the bronze dataset, we have customer, nation, region, orders, line items. We are going to use Kimball's dimensional model. I'm not going to go too in-depth in this workshop. I have an article here. You can go and read that to understand exactly what dimension and facts are, but I'll give a quick TLDR, right? First of all, Kimball is the most popular data modeling pattern I've seen in every place I've worked. Works really well. If you model your data right, it's very, very flexible. It can empower a lot of use cases. The key idea in Kimball data modeling is dimension and facts. I'll start with dimension. You can think of dimension as a business entity. So if you're running an e-commerce, you have customer and supplier. They are business entities. You will have parts. That's again a business entity. So these represent the different business entity that can interact with each other. A customer can buy from a supplier can sell to a customer. A customer can buy a specific part. A supplier can be selling a specific part. So you can see how these are related. That's dimension. And then there is fact. A fact, you can think of fact as something that happens in the real world. When I place an order on Amazon, a checkout item or a fact is generated. So that's what people call orders. It'll have information about customer ID, products, price, tags, discounts, etc., payment, blah, blah, blah. So you can think of facts as things that happen in real life being recorded. So it could be orders. If you consider analytics, it could be clickstream. So how many times did you click on X video? How many times did you click on Y video? Those sort of metrics you can calculate from fact table. So when someone says fact, it means an event that happened in real life is being recorded in that table. So when you take a step back and think about it, we have customer is a dimension, right? So you have like customer dimension. We also took out nation and region, which we'll see later, but customer is a dimension, right? And fact, you'll have things like order ID, order date, order price. Numerical values are facts identified. Yes and no, not always, because when you say numerical values, anyone can have a numerical dimension can have a numerical value as well. Facts are essentially things that happen in real life, or things that, when I say real life, it's like a part of the business process, right? So we have orders facts, which records one row per order. So each order you place will have a row in the orders table. And then you have line item, which means each order can have multiple items. So you can place an order that has 5 items. You can place an order that has 1 item. You can place an order that has 10 items. So those items will be stored in line item table, one row per item. So you can associate line item to orders table. There will be an order key that can use to join there. So that's the idea. You have customer, you have order facts and line item facts, whereas customer is a dimension. All right, before we look at the code, any questions? I also want to say that when we have fact tables, it can have values that you group by. So typically you group by dimensional values, so you can group by customer key, customer name, but sometimes in orders you'll have date. You'll usually have date of the order, so you can group by date or month to identify monthly trends. So that's considered like a dimension as well. Any questions? Sure. When I say entity, what I mean is when you think of a business usually has things interacting with each other. So I talked about an e-commerce business, right? You have customers and suppliers. They're interacting with each other, right? Those are usually what people say when they mean, those are what people usually mean when they say entity, right? These are two business entities that interact with each other, right? So for example, in e-commerce, again, supplier customer, if you consider something else, right? Like let's say bank, you have customer would be an entity or bank user, and then maybe like the bank itself is another entity, like bank branch can be an entity. So that's what we say when we mean entity. A fact is a thing that happens. In the bank example, a fact can be withdrawals. How much money did you withdraw? What time did you withdraw? Which bank did you withdraw it from? Who withdrew it? So those are what facts mean. Can we think of dimensions as columns in table? It's kind of tricky, the naming. When I say dimension and facts, I mean specifically the tables, dimension table, fact table. However, you're right, fact tables can have dimensional columns. In that sense, dimension as a column means any column that you can aggregate by. So it could be a date, it could be customer zip code, it could be supplier rating, it could be anything that you want to see metrics for, right? So that's what I mean by that's an example of like a dimension when you think of grouping by what columns can you group by. Those are usually called dimensional columns as well. Fact table rarely change, while in dimension tables, yes, dimension tables can change. For example, a customer dimension, they can change their address, they can change their name, blah, blah, blah. Facts cannot change because, or they can change depending on the type of fact table, but for the very basic fact tables, it cannot change because that's an event that happened. Unless you made there was some issue with the system, that's a reality. Like, you cannot change that. In this example, there are different types of fact tables. Aggregating fact tables and accumulating, but we're not going to see that in this session. But at a base level, fact tables do not change because they represent reality. Oh, that's right, IT-Fade. Fact is sales, etc. Dimension is customer, product. Yep, that's right. All right, so let's move on. Again, we are doing a very simple join, but I do want to say one thing. You have the customer, and I'm joining nation and region. So why am I doing this, right? One thing that you might have heard of is normalization and denormalization. Normalization is common in transactional database. That's because in transactional databases, there's like Postgres and MySQL, the access pattern is usually going to be, give me one or few rows from this table. So they'll be like, give me customer 2, give me customer 10, give me customer 11. This is for displaying in the UI. So let's say you log into your bank, you will see your metrics like your name and when you join, blah, blah, blah. Those needs to be accessed one row at a time. That's called normalized data. There are different types of normalization, but at a high level, that's what normalized data is. And most upstream systems to our warehouse is usually normalized. That's just standard protocol for web application development. When we come to the data warehouse, the core idea of data warehouse or data warehouse databases, the OLAP databases, they are meant for analytics. When we talk about analytics, what we are talking about is doing group bys on large amount of data. And these OLAP systems use something called columnar encoding, which makes it so that the wider your table is, the more efficient your querying is going to be. Again, we are not going to go into that in this session, but I'll cover it in the bootcamp. But basically, when you do columnar encoding, the aggregations are much faster because columnar encoding allows the database engine to pick only the columns it needs. It's really good at picking multiple values belonging to the same column instead of multiple one or a few rows. So it's good for accessing multiple column values. All right, so let's see what's happening here. Sorry, we are taking customer data, we are joining nation and region. So we have the nation information and region information for that customer. So what nation is he from or she from? What region does that nation belong to? So in a sense, we are denormalizing the customer data, and that's what dimensional data is. So you're like making it wider. On the other hand, in this use case, we don't have to join any data sets with our existing bronze table, so we just directly assign it to fact orders and fact line items. But in some cases, you might have to. This is especially true if you're using a technique called surrogate key dimension. So basically what that means is, it's in this link, but there are different types of dimensional modeling, slowly changing dimension 1, 2, 3 through 6. If you use that, the recommendation is to create a numerical incrementing column like 1, 2, 3, 4, 5 for each dimension, and then associate that with the fact table instead of having the natural key. So orders already has customer ID. However, when we want to track all the changes in the customer, we will keep adding multiple rows with something called slowly changing dimensions. When we do that for each customer, let's say customer 1 is repeated 3 times because they made 3 changes to their profile, we need to associate what the state of that customer was when they made this order. So we will have to associate that key to this orders bronze table to form fact orders. But since we are not doing that here, we can just directly set that as fact orders and line items. It's not really foreign key. It is similar to foreign key, but in warehouse systems, foreign keys are not typically enforced. So it's just called surrogate keys. You can define it, but it's not enforced by the database engine. All right, let's go ahead and run this. Great, that's done. So now we have bronze, we have silver. And silver, again, we are following dimensional model, facts and dimensions. What this allows us to do is aggregate data to any grain. We can aggregate with the customer, orders, and line item. We can get order level metrics per customer. We can get order level metrics per day. We can get line item level metrics per day. We can get line item metrics per month. We can get line item metrics per customer. So you see how we can aggregate things to different levels. That's why Kimball model is very good, because it makes the data available at the lowest grain. So what that lowest grain means is the smallest interaction with in real world. So in our case, the smallest interaction would be line item. So we have line item level facts, and we have order level facts as well. And that's just how this data is defined, because you can see here orders has some like additional information that are not present in line items. So using that, now when it comes to goal layer, what we have to do is we are getting the data ready for use by end user. What does that mean? Again, it depends on the end user, but usually when we say end user, if we are assuming that they don't know how to query, how to aggregate, how to properly define metrics, you want to give them data as simple as possible, typically through a BI, or better through a table that has all the metrics they need at the exact grain they need, so they can just do a select star. That's what we are going to do here. You can think of it as in two ways. You have facts and dimension in the silver, and then you can join a fact and all its dimension and call it one big table. That's what OBT is. And you can take this OBT and aggregate to different levels. So if you have customer, orders, line item, you can aggregate it to customer level, you can aggregate it to customer day level, you can aggregate it to let's say nation level, you can aggregate it to region level. So you have this OBT, and you create pre-aggregated tables for your end users as they need it. SCD is for dimension tables. All right, so that's what goal layer is going to be like. So let's see what one big table is and its pros and cons. So when we consider one big table, right, it's essentially taking a fact table and joining all its dimensions. So in our use case, we have two fact tables. We have fact orders and fact line items. We take orders, left join customer. We take fact line item, left join. We don't left join anything because we don't need it in this example, but you can think of a use case where we take line item and left join with, say, parts dimension, supplier dimension. But in this case, we don't need it for our output, so we're not doing it, but that's the idea. You take a fact table, keep it as the same grain as is, and left join all the dimension tables that are part of the fact itself. So let's look at an example, or let's look at how we would do that here. We're taking orders table and joining dimension customer on customer key. So now you have orders table with customer data. And fact, we don't have any information, or we don't need any information at this point, because we don't need parts or supplier information at the as a requirement, so we are not doing it. But you can think of a case where you would need those. So this is a simple example. Assume you have to create a wide line item, and wide is what I'm calling OBT, but you can use your naming convention. I have generally used wide in my experience, so that works well. You can use whatever you want, whatever company you're working for has that. So wide line item, let's assume you have to create wide line item table with all the dimensions that it has keys to. What are the tables that you would consider joining? I would like you to write the table names from the data model. I'll give like 5 minutes while I answer questions on the chat. OBT and data lake, what's the difference? So data lake, in my opinion, data lake and data warehouses are kind of converging people assume data lake with Spark and data warehouse with Snowflake. That's not necessarily true. They're both just processes. In a data lake, the idea is that you just dump data and you model them as needed. Whereas in warehouse, the idea is when you bring data into a warehouse, it has to be good. And this is kind of like an outdated idea. These days, the features are converging. But when people say data lake, they immediately think about Spark, but that's not always true. It's more of a process of just dumping data in and then only using data as required. And also the other idea is, instead of waiting for the gold layer, in data lake typically ML engineers or other engineers can access like raw data as well for machine learning or to experiment with it. You can type the answers to this tables to left join in the chat as well. Oh, that's right, identified. It's all storing data, modeling it, using it as needed, but it's a lot of marketing. Well, when you think of data lake, you think of Spark, and you think of data warehouse, you think of Snowflake. It's not necessarily the case. It's more a way of marketing. It's just that you want to store data cheaply in like external storage and use it as needed. That's basically what they're both converging to these days. If anyone has the answers to tables to left join to create wide line item table, please let me know in the chat. I'll give like 2 more minutes. So order, it's a fact itself. So ideally you want to keep OBT to 1 fact grain, because if you add orders here, the aggregation becomes tricky, because if you aggregate any metric in the orders table from the orders data, it'll be double counted or triple counted depending on how many items it has. So typically when you consider OBT, you want to keep it to 1 fact table level. So let's look at that, right? So let's see. Wide line item. So how does line item, what are the keys that line item has? Line item has order key, it's the fact table. Line item has part key, supplier key. Those are dimensions. Part key and supplier, parts and suppliers are dimensions. So you can join, if you had that, you would join dimension part and dimension supplier. That's basically what you would do. Again, the answers are here. So you can go ahead and kind of take a look at that. All right, so now that we have the OBT, let's go to the next layer called pre-aggregates, sometimes called semantic layer. Basically semantic layer. Basically the idea is you aggregate data to the level required for our stakeholders so they can just do select star. And one of the key reasons you want to do this is because you want to keep the calculation of metrics logic, the logic to calculate metrics in your code base. If you let people define metrics where they want, let's say an analyst creates an Excel sheet by pulling data, they will have their own definition of metrics for, let's say, revenue, and the data scientist might have their own representation of metrics in their Jupyter notebook. A backend engineer might have their representation of metrics in the backend app. So what this will almost certainly, I've seen this all happen so many times, cause is that the metrics will vary and people will start asking the data team, hey, why are the metrics varying? That's just usually how it goes. So one of the key things to do is keep the definition of metrics in your warehouse so that the end users, all they have to do is do select star and they'll have the data. It's not always possible, but for the most cases it is. When is it not possible is if you don't know exactly what grain that the output is required. If they keep on asking different grains, it might be better to give them access to the OBT table, provided they're proficient enough. But this is kind of what people say by certified dataset, meaning the data team has okayed this. Anything that doesn't look right here is the data team's responsibility. That's usually how it goes. And when you define the metrics here, you have control over it. You can change it, you can check it, it makes life much easier. Having it defined in one place instead of like BI tool, some Jupyter notebook, and backend app. Having it here makes it so much easier. But again, it also comes with its cons because now you have to define all the metrics in our warehouse system, either it be DBT or Spark or Polars. ITfied has a question like all computation during ETL only. That is right, ITfied. We want to compute as much as we can and keep it in this pre-aggregated table. That way, people are just select starring from this table as they need to. This can be done in multiple ways. Sometimes the data teams will define it in BI tool. Sometimes they will have like what's called a semantic layer. Popular ones are Cube.js and semantic layer from dbt Cloud. But those are quite expensive. And the reason is those semantic layers are automated systems, and they will do aggregations for each query that the end user makes. While that might seem fine, it will skyrocket the cost because you're re-aggregating OBT over and over again. So you got to be careful. Pre-aggregated table is a much cheaper alternative, but the con is you have to write a lot more code. All right, so let's go ahead and run this. Let's do a limit. Great, now we have the output. I will leave this as an exercise for you. Why is average order value null? It has something to do with how Polars calculates it. So I will leave that for you. So that's like a house. You can kind of investigate it in your own time. All right, before we go into data quality, I want to recap. We identified what inputs we had. We determined what output is required by the stakeholder. We saw how we can go from raw, bronze, silver, gold, which has both OBT and pre-aggregated, and end user. Again, each of these is in this itself has a lot more depth, and I have recommended lists, or sorry, recommended links, so you can read through that to go in depth. But that's like a high-level overview, and if you're building data portfolios, this is more than enough. And to be honest, most people don't do this. Most companies don't do this right. Very few companies do it. So if you do this, you'll definitely set yourself up for success. So having given that bit of overview, do you have any questions? I'll leave like 3 minutes on the clock before going to the next part. What have you said that? Doreen, what I meant by that is most companies don't follow best practices. What I am explaining here is the ideal scenario. Sometimes you just have to go with the flow. Companies don't do all this. Big companies do. When I worked at LinkedIn, they followed this very well. It was so much easier for us. But we also had like a lot of people. Small companies, they don't really do this because they don't need to. You know, like if you have 5 pipelines or 10 pipelines even, you don't need to invest so much work. You can just get something going and then change it. It has its own pros and cons, but when you're a startup, you want to get something out quicker than when you're like a larger company. So that's what I mean by most companies don't do this kind of the right way, if you will, end to end. Does that answer your question, Doreen? That's true, ITfied. This is ideal scenario. It's usually not that great. It's sometimes more just Wild West type stuff. So yeah, it is what it is. Yeah, but for projects, right? If you do this for like data portfolios, and you'll have a link below that has like explanation of how to present it. You can really impress a potential hiring manager. That's the whole kind of point of like building a data portfolio. Narendra, you mean most companies don't follow Brown? No, they don't. They try to most of the time. Sometimes they don't. those are good reasons. I'm not like putting any company down. That's like valid reason, right? Like if you have a week to get out something, you usually don't have the time to kind of understand all the input sets, understand their nuances. You just want to write some code to get some output out, and that's totally fine. It's a trade-off that you are gonna have to make with their manager or tech lead or whomever. So yeah, this is just like the ideal scenario that I'm talking about. So don't be surprised if you go to a job and you don't see all this stuff laid out for you. All right, if there are no more questions, I will keep going. Great. The next step, or the next section we are going to cover, is data quality and code testing. Data quality, we looked at two data quality metrics. One is check that customer key is unique and distinct. The other one is check variance in average columns. Some really good recommendations by referential integrity, checking numbers, which is called reconciliation checks, like checking that the output has the same number of rows as the input. That's like reconciliation check. Again, you can go through all of this in these links. I have types of data quality checks that has all that stuff. So we had some great recommendations. But for this example, we're just going to do two types of checks. One is uniqueness and distinct check on customer key, and checking that the average metric is not over 5% run over run. Again, the first thing is simple. Let's take a step back. We are going to run these checks only on the output. So what I mean by that is, when you create an output, before anyone can access it, you need to do the data quality checks, because when data is out there, it's hard to revert it, because you will have typically have multiple users using your data to make business decisions, to make dashboards, whatever. If you make a mistake, it's going to propagate to all those end users, and you really don't want that, because rolling that back is not a simple thing at all, especially with like startups. It's not like web development, where if you make a change and you put up another PR to make another change, it's gone. It's very, very complex, changing data and communicating with stakeholders. It's a very complex thing. So what you want to do is you want to generate like your data set, run your checks, and only then put that data set in another table, or naming something else, whatever it might be, you want, which is used by the stakeholder. So you want to create the data, run your data quality checks. Only if it passes, send it to the stakeholders, make it available for the stakeholders. Narendra is asking, we do data quality before the data reaches the warehouse, right? In this example, we are not doing that. However, if you go to this list and you see like types of data quality checks, how do I open this? Yeah, it's like in data engineering. If you go here and you see types of data quality check, you will have like input, mid-pipeline, output. Right now we are only doing the output. Take a look at this blog post. I have the link here that has all the different layers and how to implement them. Again, this is just like a flowchart of how it happens. You generate the data, you check, you run your data quality checks, fail or pass, you log the results. That's important. And then if it failed, you raise an alert. If it passed, you send it to the table or system or whatever that is going to be used by all our downstream consumers or stakeholders. So let's see how to do this, right? Let's look at how we will compute average changes run over run. I'm going to leave how to compute unique and distinct customer key as an exercise, because that's relatively straightforward. That's like you just do is unique and is distinct, or sorry, is unique and is not null, a part of Polar's API. Let's look at how we can check the variation between metrics of this run and previous run. So let's take a step back and think about it. There are two ways you can do this. One is compute the variance for this run, compute previous data's variance and compare them. The other way to do this is compute variance, store it in another transactional table, and then in the next run, when you compute the next metric, use the transactional table to compare the values. That way you're not always recomputing the data. recomputing metadata or recomputing this average metric each time. So let's see how to do the second one. So what we are going to do is we are going to compute the metric, store it in a SQLite database table. In the next run, we will compute the metric and get the already computed metric from SQLite table and compare them. And this might seem like overkill for this use case, but that's what typically happens with data quality frameworks like Great Expectations. You don't want to have to recompute over and over again. You want to have metrics in a place and then you just want to compare, right? But that also comes with its own pros and cons. The pro is save on computational cost. The con is if you're doing backfill, if you're changing previous data, you have to recompute the metric again. So this is just like code that goes over how we can compute this. So let's take a look at that. It's relatively straightforward. It might seem like a little bit complex if you're not used to data frame, but basically what we are doing is we are computing, well, I'm just selecting average numbers and aggregating to sum. So I'm grouping by all the rows and computing the sum. It's not really a great metric because sum of average is not usually a good metric, but that's what I'm choosing here. What you can consider is like considering average number of items per order by zip code for customer or by customer itself. So those are more advanced techniques you can use, but to keep it simple and kind of within time, I'm just calculating it for all rows, aggregating, calculating sum, and I'm inserting it into a table in SQLite. It could be any database, usually like MySQL or Postgres, any transactional OLTP databases. And then assuming we run the second run, again we get the most recent one, we compute the current one, and we compare percentages. So here, I'm not going to go over the code, it's pretty straightforward. You just compare both and see how much it has changed. And if the change is greater than 5, we raise an exception. So it's relatively straightforward. You're just computing percentage difference between this run's and previous run's metric. If there's no previous run metric because this is the first run, we can ignore this because it doesn't matter. Yeah, and then we store what we computed again in the table. So each run, what will happen is we'll compute the metrics, compare it with previous metric. If it succeeds, we will or fails, we will store the result, and then we will raise an alert if it fails. Yeah, or by products identified, it depends on how you want to define it. I'll typically work with a subject matter expert because they usually know the trends in data. This is going to be like a homework exercise. Read through this, excuse me, read through this code. There is a mistake in this piece of code, the one right above the exercise cell. So take a look at that and see what's wrong with this code. All right, so now we saw output data quality checks. I'm gonna wait for like 5 minutes for any questions before we move to the next section. ITfied has a question. What do we do with invalid data? If we remove that, it may result in data loss. So what typically happens when we have invalid data is we don't make it available to the stakeholders. We have the invalid data, we will store it, let's say in something called temporary table or whatever naming you want to give, usually by like data underscore run ID. Run ID will be the datetime that the pipeline is collecting the data for. And then a data engineer will use that to debug to see what failed and why it failed, right? And it's not really data loss because the data is incorrect. So that typically means either the input set is incorrect or there's something wrong with their logic. So it's not really data loss because it's bad data. You don't really need it. You typically, what you do is you debug, make a change, push it to the production pipeline, rerun the pipeline with the same input, and if you get the right, if your data quality checks pass, you will make it available to the stakeholders and store the data. So the idea is if it doesn't pass the data quality check, it's just not data we can use. Does that answer your question, ITfied? All right, if anyone else has any questions, please let me know in the comments. Looking at that. So Viresh asks, how do we do backfill? How do we backfill the data in case of failures or source data changes? That's a good question. So we typically do backfills when we either find a issue with the input or something wrong with the code logic and we have to do backfills. What we typically do is, it depends on the type of pipeline. In this pipeline, we are doing something called a snapshot pipeline. Basically, we are just pulling the entire data. We are doing, we are doing, if you see here, we are doing a select star from the input. Where is it? Yeah. So here you can see select star. So we are choosing the entire data set. This is called a snapshot pipeline, meaning we are processing the entire set with each pipeline. It just makes things so much easier. However, there are pipelines where you only process like data belonging to a certain date, etc. Right? If you have to do backfill, if it's a full snapshot backfill, all you have to do is just run this snapshot, because usually when snapshot needs to be backfilled, you don't care about the past. You only care about the current one because you know all the data is in there. However, if your inputs, you're pulling for certain time ranges, so let's say you're pulling only 1 day's worth of data for each pipeline that's being run daily. If you backfill 5 days from today, you can transform just that data and put that just into the put that into the output. So that's called like an idempotent pipeline. Let's see here. I have a link to one of those. So it depends on how you design the pipeline. Snapshot pipelines are the easiest. Where is it? Yeah, I'll go here and take a look at it. Yeah, it's in here somewhere. So snapshot pipelines are the easiest because all you have to do is just rerun the pipeline. However, idempotent pipelines, which involve processing chunks of data belonging to a certain time ranges, you typically have something called the run ID, which represents the start and end time. So you can just reprocess that chunk of data. There are some caveats here because the source needs to be able to sustain that data for whenever you need it. That's why you typically just get the data and dump it in the raw layer. That way you can just reprocess it if you need to. But yeah, that's how you do it. Does that answer your question, Viresh? Oh, thank you, Siwark. I hope I'm pronouncing your name right. Narendra, yes. In the bootcamp, I'll be using Spark, again with Medallion. There is also SQL DBT. Yeah, I'll send out the kind of tools and chapters in like next week or so. Yeah, but yeah, it's going to be Spark, and there is a section on distributed systems with Spark. All right. So if there are no questions, let's move to the next section. Oh, Viresh has a question. How do we design such pipelines? Do we have any references? I'm not sure. Like, how do we, what do you mean? Do you mean like how do you sell it to the management, or do you mean like do we have any honestly, the designing pipelines, you can come up with your architecture, and if you pitch it and your team is okay with it, just go ahead and do it. Like references, basically I built this from my experience working in the industry for 10 years, from what I've seen in small and big companies. So that's basically my reference. Oh, you mean backfilling? There's a section on backfilling. It should be in one of those links that will explain how you do backfills. Go to design patterns on my post. So if you go here, right, if you go to data flow patterns, so here, right, you go to extraction patterns, you will see kind of like the different types of extractions you can do. One of them is snapshot, being the easiest. Fault tolerant, again, associates with functional coding and how you organize your code. I'll go over in depth in the bootcamp. I honestly don't have time. That takes a long time to go through. Doreen, I'll leave the link below on how to join. IT5 basically problem scoping. Yeah, that's true. You really need to make sure that your requirements are solid before you start anything, because if your requirements are not solid, by solid I mean you should be okay with it, you should know exactly what it means, and the stakeholder should know exactly what it means. What are the grain? What are the metrics? Get them like a sample data set. Does the metric match their expectations? You do not want any surprises. And this is especially important with data pipelines, because sometimes they take a long time to develop, right? Like you need to understand the inputs, which sometimes are just a huge mess. In this example, it's super easy because the data is so well modeled. I've seen cases where data is missing, tables have multiple grains, like one table can have fact and dimensions. It's just a mess. So you need to spend a lot of time understanding the input data. The requirement as well, but in my experience, understanding input data, especially in larger companies, is takes a huge time. Coding is the easy part, right? Understanding inputs, clearly understanding outputs, and getting sign off from stakeholders. Those are like the biggest time sinks, especially when you get to like design like higher levels, like senior staff. That's basically what you're going to be doing. And this involves data quality as like, what is data quality? How do you define data quality for that data set? Right? That's like the tough problems. Code is pretty straightforward usually. Well, it can be a mess too, but usually that's easier to change than not knowing requirements or not knowing the input data sets. All right, so let's go to the next section, right? Code organization. We saw medallion architecture, but it's the same thing with DBT as well. So let's look at how we can organize our code in this medallion architecture, right? So we can create a project called DE project. Just not a great name, data engineering project. One thing I've seen work really well is ETL and have bronze, gold, silver. Makes it super explicit, and each table has a single Python script, right? So you can see bronze table in the bronze folder, gold tables under gold folder, silver, and code testing, which we'll see soon, right? So what does that mean? Let's take a look, right? Or actually, before we look at that, this is going to be our code structure, right? If we compare that with DBT, and this is from like DBT official recommendation, you can see that staging is sort of similar to bronze. They have base, which is like raw, or they used to call it source, now they turned it to base. Basically means the data as is from the input. They change it a little bit. They have different recommendations, slightly different from our recommendation, which is data types and data naming. We call it bronze, they call it stage. Then they model it into intermediate, and they model it by what is that, verticals or teams, right? They can have different models, but it's usually better to have dimensional models, meaning Kimball model, because it's so versatile. And then they have marts, which is similar to gold OBT. So these are very wide tables. If you go to their example, I have the link here as well. Okay, if you just Google DBT project, this is what comes up. So their marts are similar to gold OBT. It's not pre-aggregated, and that's because they have semantic layer, which does aggregation on the fly as needed, and that's where costs shoot up. Depending on your use case, you may want to prefer that, but you need to have DBT Cloud, or you need to have a system like Cube.js. But for smaller systems, something that's handleable, something you know the stakeholders are not really great at metric calculation or understanding data, a pre-aggregated layer is usually good. Yeah, so that's basically how DBT and Spark, data code organization and data flow organization are similar. All right, before I go to the next section, which is how to write code modularly, any questions with the folder structure or code organization? Maybe like 3 minutes on the clock. No questions with the code organization? All right, let's go to the next section, which is code modularity. So now we know how to organize, or where should our code live. The next part is, what should the code look like, right? I have again recommended reading here, please go through that, but ideally, or essentially the idea is to write modular Python code. So let's take a look at what that means. IT file asks, what does each file have? We're gonna see what each file is made up of. IT file, that's what code modularity section is about. So when we take a step back, let's think about what's happening when we create a table. Any table, silver, bronze, or gold, we have a set of inputs. For bronze, it's going to be raw tables. For gold, it's going to be, if it's pre-aggregated, it's going to be OBT. If it's OBT, it's going to be silver. For silver, it's going to be bronze. So you have a set of inputs, you have some transformation logic, and you have an output. So you have three tasks, ETL, if you will, right? You're extracting from inputs, you're transforming it, and you're loading it into an output data set. So that's essentially how we are going to model it, because modeling it or organizing your code in such a way makes it easy to kind of take out the common patterns and move it to a different file that can be reused by systems. This is a part called metadata, basically the code that kind of stores our metrics in that data quality table. Go over this at your own time. It should be relatively straightforward. It kind of goes over how you get the latest run metric or the most recent run metric, and how do you kind of insert metrics into that table. Let's look at one of the examples for pre-aggregated table, right? So we have, if we look at this, we have customer outreach metrics. That's what our output is called. And we know it's a gold table. We know it's a pre-aggregated table. This path is critical, because when you're exporting this file, when you're exporting functions in this Python script to anywhere, it's super easy to understand what this does. So you'll say from ETL gold pre-aggregated import customer outreach metric. So you know it's a gold pre-aggregated table. Kind of having this explicitly defined makes your code so much easier to read. So what exists here? So let's see. So you have create dataset, which basically takes your inputs and returns the joint outputs, right? It just does the aggregates, because this is the final pre-aggregated table. So it takes the OBT tables as input, and then it has the calculation to compute differences. This has the logic to compute that customer key is not distinct, it's unique, and this one kind of checks the variance, and this one checks the validity. So a couple of things we are doing here, right? We create a function for transforming. You can call this transform. I call it create dataset. Ideally, you want to call it transform. And then what we do is validate dataset. Validation involves two steps. One is checking that there are no duplicates, and checking variance. And we have the logic defined here. So that's all we are doing for now, right? So one thing when we are defining functions, right, one thing you want to note is the function name ideally should be verb and noun, meaning doing something on something, right? Creating dataset, it can be transform as well, that's the same thing. Validating dataset, so you're doing something on something, so like checking variance, checking no duplicates, right? So that's typically how you want to name it, easy to kind of use and understand. I'll leave this as an exercise for you. This is kind of like a complex logic where you compute this runs metric, compare it with the previous runs metric. There's answers here. Just think about how you would make it better, right? Again, the code is all in the DE project ETL space. So let's take a look at some bronze tables, right? All it has is create dataset, and you have some default values, and all it does is pulls data. And if you go to silver table, it gets the bronze tables, does some transformation. We don't have any data quality checks here. We ideally should, but in this example we don't, and then gives you the output. OBT line item, we don't have any join, so we are just returning it as is. In white orders, we are taking fact orders, left joining dimension customers, and we saw pre-aggregated where we are getting these two white tables or OBT tables, computing metrics, and validating dataset. So one thing you can I want you to think about this, right? The same pattern repeats you're creating data set. Each data set has some inputs, and you're not writing it out to any location for now. You're just returning it, right? You're just returning it. And then we have a script that basically just runs all of it, right? So this is what I mean, right? Inputs become super easy. You say, from bronze, I need customer, line, nation, blah, blah, blah. From silver, I need all this. Gold, I need this. Pre-aggregated, I need this. So let's see. This is the output I want to give. Before that, I want to validate it. I want to compute it. So we are just basically computing all the tables here. One thing you might note here is that we are not saving the output anywhere. That's okay for this example. But as a part of the next step, we should kind of store those tables in a location. And if you want to go into this in depth, again, go to my web page or my blog, and if you go to, actually you can go to GitHub, and there's a Spark code I have that goes over this in detail. So if you go here, go to Capstone, this has a more advanced representation of how this can be done with like classes and stuff. Again, I'll cover that in detail as part of like my bootcamp, but we don't have enough time to go over all the nuances. But the idea is same patterns. The only change usually is the input and the transformation. So I want you to think about that. All right, before we go to code testing, this is not data quality testing, this is code testing. Any questions? Put like 5 minutes on the clock. Please let me know in the chat. Any question with code organization? Why is it organized in a certain way? What do you think can be better? What do you think is not good? Okay, Charles asked, what guide do you use in coming up with data quality checks? So honestly, there's no single source, and that's because when we say data quality, it's such a wide thing, right? Like data quality can mean any number of things. Some people define data quality as just checking the output. Some people define data quality as data freshness. Some people define data quality as how the data looks in the BI tool. So the best thing you can do is first of all, talk with your stakeholders, understand how they think about data. They typically have a few metrics that they will care about a lot. These are things like revenue, conversion rates. They don't want that to like shoot up or shoot down without just cause. So that's where you start, right? And if you want to go deeper into that, I do have an article, and again, I'll cover this part of the bootcamp. Here I'll go through like different types. Like you have table constraints, which is like not null, unique, completeness, referential integrity, meaning it can join to another table completely. You have business rule checks, you have table schema checks, you have metrics variance checks, which is what we did. You have distribution checks, which is similar to metric variation, but grouped by certain dimension. You have reconciliation check, where you check that the output, let's say number of orders and the output is the same as number of orders in the input, and then things of that nature. So those are the main ones. You can do as much as you want, but the thing is, you can also go overboard with the data quality checks, because you can do so much. So it's critical to identify the crucial ones first, and then kind of build out from there. I would recommend just getting the crucial metrics checked first before kind of thinking about like so many data quality checks, because it's such a wide thing, wide field, and you will constantly have to update it and change it and refine it. So it's better to just get started. Hope that answers your question. Charles, what used to happen before DBT as ITfied? Before DBT, people are doing this in Airflow. People were doing it in Spark. People were doing it in Pandas, just like what we did here. So DBT is, from what I've seen, DBT is not anything new. It just enables good patterns much easier. So instead of us having to define like, oh, transform and validate, it already has all this built in. All you have to do is write a SQL, which is essentially what we are doing here, right? Convert this data frame into SQL. There you have DBT. So what DBT did was it made the creation of pipelines easy. So all you have to do is write SQL queries. It established some great patterns like base and stage and intermediate and merge, and it established CI/CD pipelines. It established lineage graphs. So it's like a lot of quality of life improvements. A lot of companies were doing that, but so many other companies were not doing that, and they were struggling. So when DBT came along, it was easy to adopt, just SQL, and it was easy to get going. You can set it up in like 10 minutes. It's super easy. So that's why DBT kind of blew up in popularity, because it's so easy to use and it's quite powerful. So yeah, that's the TLDR of what was happening before DBT came along. So then ask, what level of Spark do we need for the bootcamp? I would say like knowing that Spark is a distributed system, because in the bootcamp we go over some Spark patterns, like how to do data frame transformations, but we'll do that, right? And then we'll go into things that are necessary for real life and interviews, right? Like what's partitioning, how does it help, what are its caveats, what's clustering, what's how do you store data, how do you sort it, do you bucket it, do you cluster it, and what is wide transformation, what is narrow transformation. So when you think of Spark, right, the APIs or data transformations are very similar to Pandas. You can Google it, it's super easy, right? Like same as Polars, it's the API is easy. But when it comes to Spark, because you're dealing with such a large data set, usually you need to understand the underlying principle, like how do you cache it, do you want to cache it, how do you distribute data, how do you store data for efficient querying downstream. So those are the main things that we'll go over. Thanks, Charles. That's exactly right, Doreen. DBT really helps automate data pipeline creation. Again, I have a post on that, so if you have something, you can just go to DBT tutorial. It goes over how DBT works in detail, so check it out if you like. That's pretty good usually. That's true, IT Fight. It does reduce laborious work. It makes things so much easier. I do want to specify though, DBT does cause a lot of issues, because yes, it makes things easier, but without the rigorous engineering process behind building data pipelines, DBT can become such a mess. I worked with teams where analysts were just creating SQL models left and right. Snowflake costs were skyrocketing, and we had to come in, do an audit of what's costing so much, what pipeline is costing so much, and then kind of have to rein it in. So yes, DBT makes it easier, but the caveat is it makes it easy to spend a lot of money as well, and you don't really want to do that, because Snowflake costs can go like 200K, 300K, increase so much because you have so many SQL models. And the main thing with data quality checks is people write a lot of data quality checks, which is great, but each check is run as an individual query. So it'll do one query for not null. It'll do, if you have not null and I don't know, uniqueness checks, it'll do one query for not null, another query for uniqueness. So it does a lot of cost expensive work. So it's great to get started, but you need discipline. Otherwise, those costs are gonna hit you hard. All right. Any other questions? Okay. All right. Seems like there's no more question. Okay. So we built the entire pipeline. We have some data quality checks. We organized it well. It's in the DE project, and we have a script which we can run too. All we have to do is run this Python script, and it will create our output, or just print our output in this use case, right? So we have everything. One of the main things that you want to do here is test your code, not your data, but your code. So what does that mean? That means you have transformation logic. You want to make sure that the logic you have does what you think it's supposed to do. And that's basically what code testing is. You can click on this link to kind of read about PyTest in detail, which is the tool we will use. But at a high level, you can think of it in two ways, right? There's unit tests and integration tests for this use case, at least. Unit tests will check transformation functions, like a single unit of code. Integration tests will check integration between two systems. Typically, is your data transformation tool writing to your data storage system? Is Spark writing to S3, or is Airflow triggering Spark, or is Spark reading from the SQLite table we have? So that's what integration testing is. So in this use case, we have unit testing, but please read through this read through this link to understand how PyTest works in detail and how to think about testing code. Again, I'll go over this in detail in the bootcamp, but we don't have time now, so just go through that link. It gives you a good idea. Typically, you want to place it in the same location as your ETL code. Makes it easy. So we have a unit test called test dimension customer. PyTest has this thing where if you name the file test underscore file name, it'll automatically identify that file as containing test cases, and then it'll look for functions that start with test underscore. You can modify, you can say, you can tell PyTest to look for other naming patterns, but this is like the standard one, so just use that. And they have something called fixtures. When you think about fixtures, what that means is fake data for testing. You always use real data for testing, because if you're testing locally, you might not have access to data. If you're testing like 10,000 row table, you might not have access to that data. So you create what's called a fixture. So in this example, we create fake region data frame, and we say PyTest fixture. What this does is it enables us to use that as an input argument to our test function. So you can see here we have some fixtures, basically fake data for testing, customer data frame, nation, region. So we are testing how dimensional transformation function, is it working as expected? So what you do is you create the data set, you run the function, you get the result, you have some expected data frame, basically what you expect the output to be, and then you make sure that it's equal. That's all PyTest does. This is a simple test case, but if you want to learn more about how PyTest works in depth, I strongly suggest you go through this link. It's really good. It has like how to think about PyTest, what are the patterns you can use so that these fake data can be reused across multiple test files, right? Like here you're just testing dimension create customer. You might want to test wide line item. You might want to test wide order. So for all those cases, you can just reuse fake data. So take a look at that. I'd recommend taking a look at that. And then finally, you can run this in your terminal, and in Jupyter Notebook, if I put exclamation, it's basically the same as running it in a terminal. So you can run this in your terminal. So you do this, blah, blah, blah. Okay, it passed. So it ran the test. It ran one test because we only have tests, and it passed. That's it. And I mean, we can do a simple example, right? So if you say like diff test sample return false, it'll fail because we are returning false. There you go. Oh, what? Oh, sorry, you are not supposed to return. You are supposed to assert with the PyTest. So you can say, you can check if 1 is equal to 0, right? So you say like, it's saying 1 is not equal to 0, right? So that's how it works. The last statement has to be an assertion. Assert basically checks if left value is equal to right value. Here we use assert frame equal. It's from Polars. That makes it easy to compare data frames, right? So you can see Polars testing. That's it. All right. So we saw the code part of it, right? Before we go to the orchestration, I want to actually show you how to run this code. Oh, this. Okay. Let's see if we can preview this. There we go. So it's pretty straightforward. You can first thing is you create the input data, which we already did, but we can just recreate it if we need to. Once we create the input data, we can run some tests or run the pipeline itself. So let's run some tests first. Great, tests pass, and then we run the pipeline. This should print out our output, because that's what we're doing. We're printing the customer outreach metrics, which is the output we defined. There you go. So our pipeline works pretty straightforward, just a bunch of scripts, right? Great. Now that we have a script, we need to schedule it. We already orchestrated it, meaning orchestration essentially means connection of different tasks involved in a data pipeline. And we have done that by separating our tasks, our pipeline into bronze, silver, and gold. So we have bronze, gold, and silver. However, it's being run as one Python script, right? So that's usually the orchestration part. In Airflow, typically what people do is they have like a Docker container for each orchestration system, and then they kind of run that per task. Again, it depends on the company. My experience is that Airflow is great for scheduling and some orchestration, but it's really hard to test. So ideally, so typically what people do is they put all their pipelines into like one or a few scripts, and then they just use Airflow to do A, B, and C in order that they need. So that's orchestration. Scheduling basically means running data at a regular interval, let's say every minute, every 5 minutes, every 10 minutes, every 10th day of the month, whatever you want. You can do this in Airflow using cron or its scheduler. So let's go ahead and do that. So if you're doing this the first time, you want to create the input, which we already did, and this sudo thing you want to run in the terminal, because it doesn't really work through Jupyter Notebook, because it has sudo, especially if you're running it locally. Not sure why the video format is not supported, but it shows how to run this via terminal if you're running it locally, right? And then we create Docker containers. I'll take like 30 minutes actually, or sorry, 30 seconds or 5 seconds or something. If you're doing it the first time, it's going to take a while. So while we let that run, let's see what it will look like, right? What we are doing here. We are initiating Airflow, and then we are doing a Docker compose. Again, I would recommend going through this. Where is this Docker link? Oh yeah, Docker for data engineers, to understand Docker in detail. But ideal kind of TLDR, what it's doing is it's creating containers to run Airflow, so that we can kind of see the UI and see it run basically. So it's starting Airflow. It takes a while. So while we let that start, I'm gonna take questions. If you have any questions, please feel free to type it in the chat. Atish asks, is Airflow combined with Kubernetes good for data orchestration pipelines? It's great for data orchestration pipelines, Atish, but you need to be able to manage it. You need to know how to connect Airflow to Kubernetes. Do you have a DevOps team that does that for you? Because that's a lot of work, unless you're paying for like some sort of managed Airflow system like Astronomer or managed Airflow from AWS, whatever, right? You need to manage it, and that's usually very, very difficult. But if you have like hundreds and hundreds of data pipelines, that's usually a better, that's usually a good idea to do it in Kubernetes. However, I've had really good experience with like a standalone Airflow EC2 instance that allows us to run like 16 pipelines up to a time. It's pretty good for like a small to medium-sized company. Don't overcomplicate it, because Kubernetes is quite complex. You need to be able to connect to it and set up the YAML configurations and things like that. So if you're familiar with that and if you're good at that, sure, go ahead. And if you have a team to manage that, yes. But if you're just starting out, I wouldn't go the Kubernetes route, especially if you only have a handful of pipelines. Please let me know if you have more questions, Satish. ITfied asks, what do you recommend, Airflow in Python environment or containers? That's a tricky one. I usually prefer containers, because Python environments may work, but sometimes it refers to the original Python installations. Especially it gets tricky if you are installing not just Python but some other jar or something like that. So for example, if you want to talk to a Spark cluster, you need Spark jars from Airflow to talk to a Spark cluster. EMR is handled for you. But in those cases, having containers are super easy and makes the integration smoother. compared to Python environment. However, if you're just in this case, right, you can just do Python environment because all our stuff is in Python. It's just polars pip install Python, right? But when it comes to Python environment, our containers, you need to manage Python dependencies. So what that means is requirements.txt has like pinned version, so I'm specifying versions. But there are tools you can use to manage Python versions like pip environment, UV, things like that. So you probably need that when you're dealing with kind of installing Python tools. Let me know if that answers your question, ITfied. Lethal Naijas, so how do we integrate the test with Airflow if we can already orchestrate the pipeline? So this comes back to the kind of what does testing mean? Testing, we don't need code testing as part of your data pipeline. Code testing is done in your local development environment to make sure that the code does what it's supposed to do. Once it's done, once you test it, you can be pretty sure because it's not going to change. The test code is not going to change, right? Let's look at this, right? It's the same thing. You're testing with these fake data. You're making sure your output is something that you expect. So the idea behind testing is you test it locally, and then when you do CI/CD pipeline, you test it in CI environment and CD environment sometimes. Basically, you don't run code tests as part of your pipeline. You do run data quality checks, but when it comes to code testing, you don't run it as part of your pipeline. It's just before you deploy to production, test should pass. That's the kind of idea behind tests. So there is a post I have. So it's like CI, how is it? Yeah, take a look at this, right? It goes over like how to do what does testing mean? Like how do you run tests before pushing? What does testing actually achieve for us? Let me know if that makes sense or if you have more questions. Later, Naija. All right, wonderful. ITfied asks, just to summarize, simplified project, Python environment, complex or many dependencies container. Yeah, that's about right, ITfied. I'd like to keep it simple usually as much as I can, because these days with Python tools, you can go a long way. Like with DuckDB or Polars, you can run DuckDB and DBT, and you can kind of process like hundreds of GBs almost. So it's pretty straightforward. But yeah, sometimes depending on your existing architecture, you probably want to have containers. Okay. Ankush asks, what are you putting inside the Docker container? That is a good question. So what I am doing here is, that's a very good question. I should go with that. So first, actually, the Docker container is up. Let's look at the UI and I'll go over that, right? So 8080 is Airflow. So let's open that. This is going to be really slow because the code spaces is a tiny machine and Airflow is pretty heavy. But let's wait for it. You gotta refresh a couple of times. It's pretty bad stuff, or not very good. All right, while we wait for that, I'll go over what it does. All right, let's wait for that to set up. So what happens when it comes to Airflow is you need something called a DAG. A DAG is a again, go over my Airflow posts. I go over all this in detail, but basically a DAG is a directed acyclic graph, basically a data pipeline. So I'll say like, hey, this DAG, run this create customer outreach metrics, which basically is from run pipeline. So if you go to run pipeline, you can see create customer outreach metric, just prints the customer outreach metrics. So I'm saying like, just run this task and stop the pipeline. That's all it does. And I'm putting the entire DAGs and code inside the Airflow container. So I'm saying like, take this code and put it inside the container. Now run the code inside the container so I can access Airflow. Wow, it's taking forever. All right. There we go. All right. So once we put the code into Airflow, you can go click on that link. It takes a couple of tries. You might have to close and open it, but it's Airflow username password. You get in there, It takes a couple of times. Honestly, it's pretty slow because this code space by default is really small machine. So let's wait for that. But basically, this DAG will create a data pipeline in our Airflow system, which we can then start. And characteristics of DAG, the main one is the name, some description, and we are saying it needs to run every minute, and it should start 2024 9:23, and you don't have to catch up, meaning if you start today, it doesn't have to run every minute from 9:23 till 9:28. All right, let me see if it opens again. All right, so here it is. Let's start this and go here. It should be relatively quick. So all our pipeline does is just create customer outreach metrics and then stops the pipeline. It's relatively fast, so there you go. It runs every minute and boom. So there you go. We already ran 2 pipelines. So that's about it. There you go. You have your Airflow pipeline. You can see DAGs, and right now we only have one. Basically, it needs to have this DAG defined here. Then Airflow will recognize that as a data pipeline. Okay. Okay. Define asks, could you explain Docker Compose and Docker Compose? Sure. Again, go through this post. It's a little bit in depth. I don't have the time right now to go over all of that, but basically what it does is it looks for this Docker Compose file and it builds a virtual machine. Think of it as this, right? It builds a virtual machine from this file called containers Airflow. So let's take a look at that. Let's go to containers. Let's go to Airflow Docker file. So all we are saying is use this version of Airflow, copy the requirements, install the requirements. Don't think about this right now. This is in the next session. Basically, it's for data visualization. So all you're saying is use the official Docker image of Airflow and install some requirements. And Docker Compose will use that and set up Airflow environment, and it'll set up Postgres because Airflow uses Postgres to store the run ID and run data, things like that. That's basically what Docker Compose is, right? So when we say Docker Compose up Airflow init, so Airflow, setting up Airflow requires 2 parts. One is Airflow init. Basically what that means is it'll create all the tables necessary to store DAG information, run information, things like that. And then Compose up will start the service that actually starts your pipeline and starts your pipeline on time. So you can think of it as like a constantly running web app that every minute will see if your code needs to be started. That's basically what it does. Does that answer your question, Daifan? I know that Docker is a little bit complex. I don't have the time now. I'll go over this in detail in the bootcamp, but please go over the link. That has some good explanation. Viraj, you have so many blogs. Yeah, I've been writing for like 4 years now, so yeah, just go through that. It's not very well organized. I want to put together like a learning map. It's just all over the place, but yeah, it's all there. Most of it is there. Ankush, second question, do you use Docker Compose for managing containers? No, usually not. Docker Compose typically we use for local. Some companies do use Docker Compose for production. It works fine. It's called Docker Swarm, because Docker Compose you only start like 1 or 2. When in production, you might have like, so what happens is DevOps sets up the production environment, right? Initially with most companies, they set up the application development side. So application means your backend server. They typically have multiple servers. So DevOps will use like either Kubernetes or like some other systems like to run Jenkins or whatever to run containers in multiple virtual machines. Whatever system they use is what's going to be used. So if they use Kubernetes, it's going to be like charts, YAML charts. If they use something like EKS, it's going to be Docker containers but managed with a different system. So again, it depends on your use cases. But having said that, I have used Docker Compose for managing containers in prod, running like really large pipelines, meaning large input data sets like terabytes and petabytes sometimes. So it works really well, but it takes DevOps skills to set that up. Viraj asks, can you share a list from where we can go one by one? So there is something I have on my thing, right? So if you go to my repository, I think it's D101. Yeah, this should have your kind of list. Basically, this is the list I would go over and go through the posts corresponding to the kind of item here. So for example, I don't know, if you go through what do data engineers do, just go search for it. Here, responsibilities of data engineers. I should probably link that, but that's what I would recommend. Hope that answers your question, Viresh. Doreen asks, is Airflow free to use or we need subscription? We do not need subscription for the open source version of Airflow, which is what we are using. However, if we want to use it in production, you either need a team to manage it for you, or you would use like some sort of managed service like Astronomer or AWS managed MCAA. But yeah, most of the time you just use the open source version, and it has all the things you need. Atish asks, how do we create data orchestration pipelines if we were to source data from different systems and put them in S3 and monitor them easily? So that's a good question. So if you want to create data pipelines with different systems and put them in S3 and so I'll answer the first two, right? Different system, put them in S3. It's the same pattern, right? You're extracting. It doesn't matter where you're extracting from, right? You can extract from SFTP, Paramiko. You can extract from a data warehouse database. Python has client libraries for most databases and warehouses. API, Python requests, CRM systems, things like Salesforce and HubSpot, whatever. They all have Python connectors, so you can use that. Or alternatively, you can just use Fivetran. Expensive, sure, but you don't have to code, right? And you can put it in different destination, right? And monitor them easily. Again, kind of taking a step back, Fivetran does the monitoring for you because it's paid, but you would have something like Datadog or New Relic or whatever to do your monitoring. So if you look at this, right, parts of a data system, so you have monitoring and alerting. That usually does the monitoring and alerting for you. Does that answer your question, Atish? Great. Let me know if you have more questions. Lethal Nija asks, okay, that makes sense. So when it comes to production, how do you run Docker Python script? Do you do it in machine with Airflows? Well, that's a good question. So sometimes yes, but most times, well, let me take a step back, right? Your question is, do you run the Docker in the same machine Airflow is installed? So there are two ways to do this. One is yes. That is typically when you use Docker to trigger some other service. So you trigger a Databricks to run SparkJob. You trigger Snowflake to run dbt. You trigger, I don't know, Lambda to process some data. So in a sense, you're not processing data. You're just using a Python process to do something outside the Airflow system, right? Airflow system is heavy, so you want to make sure that the processing is done outside the Airflow system, which is not the case in this example because it's being done in the same system. So that's how you typically do it. If you were to do processing in the same machine as Airflow, Airflow is going to be really slow. And if you are restarting Airflow or something, you will lose the data. So I typically tend not to do that because sometimes Airflow hangs. You might have to restart it. You will lose your data. You have to rerun it. So typically what people do is use the Docker to trigger an external system. dbt run. It will run SQL, but it will run it in an external system. So Snowflake or Postgres or whatever. So that's how you typically do it. In our case, that's not how we are doing it. We should probably do it that way. That's a great point, Lethal. Please let me know if you have more questions. That's right, ITfied Airflow is a free Python package. It's a Python package and also a server. So when I say Python package, what I mean is, it has like Python libraries, like Python modules like DAG, TAS, blah, blah, blah. And what I mean by a server is actually running software that you can see via the UI, right? So it's like 2-in-1, so it's a little bit tricky. If it's just a Python package, I would have just used pip install. But since it's a Python package and a container, and a service, I'm using both pip install Airflow and running a Docker container. Airflow is usually running in some cloud machine. That's right, ITfied. When you're starting out, if you have a few pipelines, you run it as a single local mode in like a EC2 or something, and then take it from there as your system grows. In my opinion, you can scale it quite a bit with just one machine, because if you make sure that the processing does not happen in the same machine as the Airflow Airflow running on, you can just trigger some other processor to do your processing. Then it scales really well. So yeah. Ankush, this is 10 out of 10 content. Thank you for the kind words. I appreciate it. Oh, we are at time. Let me see if there is anything else I missed here. Okay. I'll quickly go over this, right? You have like, this is this screenshot of what we saw. You can stop the Docker containers with this. So this is great, right? So you have everything. You have like requirements, you have inputs, you have outputs, you have the data flow, which is like, I can assure you this is industry standard and not a lot of people do this. So this will be like good to have on your data portfolio, right? But I would recommend you go through this post, right? Let me open this post for you. That kind of helps you decide what to build. Here I'm just using TPCH, which is great. I would recommend you start here, right? But when you're thinking about data portfolio, typically the objective is you want to grow your skills, meaning you want to choose the tools you want to work with, or you're job searching. Again, typically Spark and Airflow will get you 90% of the way, right? I would go through this link that's in what data project to build that goes over how do you decide what tools to use and what data to use and where to find data. And this is where you do research, right? So you look at some, for example, this is from Netflix, you look at what they're looking for. You look at languages and things they're looking for. Product mindset means you want to work well with end users. Distributed systems, data modeling, data code and quality. So you think about those things, right? And then if you're reaching out to a referral, right? Let's say you're reaching out to me on LinkedIn. Don't just say, hey, this is me, this is my resume, find a job for me. You have to make sure I get something out of it, right? Like if you're asking me, yes, if you get the job, I get $5,000 usually in most companies, right? Research me, go to my profile. This is my profile. Look at the tools I use at the current job that you're wanting to referral for, right? And then meet me in person at some meetups or even on LinkedIn. Make sure it's a win-win. Demonstrate your value, right? And you can do that by going through all this company research, using the right data, or generating fake data with AI, which I do here. It's pretty easy, to be honest. And then there is another post which shows you how to excuse me, how to kind of quickly show value, which is basically tools used, architecture. We have to add data visualization. I don't have the time right now, but that's key. And that's in the next session, probably in my bootcamp. But yeah, you want to show the hiring manager or the referral that you are worth their time. If they spend like 10 minutes referring you, they can get $5,000 or whatever referral bonus most companies have, right? That's how you want to think about it, and kind of go through that link to decide what data portfolio projects to build. If you like this kind of approach with like workshop and with code, where you code along with me, I'm doing like a 3-weekend workshop. So it's pretty intense. It's like 3 full weekends, so like 8 hours. There will be breaks. Unfortunately, we don't have time for break now. So please feel free to sign up here. It's on Eastern time and Pacific time. Also, I would love it if you can give me some feedback, kind of what you understood and what do you think about it, right? Again, that's good. The next steps, so now you have all this stuff, right? You have the base, you have most of it taken care of. Now you want to make sure you use a good data quality system. Again, the links I have in this post will take you to Great Expectations on how you can implement that. Use that instead of doing your own. How to create visualization dashboard. Again, I have a link for Quattro, which makes it super easy to create dashboards, and kind of go through some of the code. Again, I mentioned looking through my Spark code. Yeah, and moving to the cloud with Terraform. That is a big one I haven't covered yet. And then monitoring and alerting infrastructure. So like, what happens when pipeline fails? What happens when data quality fails? There should be a process. What is that process? How is it? What happens when the pipeline fails? Does no one monitor the pipeline? How will the other monitoring system know that a pipeline fails? So those sort of things you need to think about. But that's like a little bit advanced. So I would say like at least do 1 through 5. That will really give you I'm 100% sure it'll put you leagues above a lot of other folks. Sorry, we are 5 minutes over time, so I'm gonna be here for like 10 more minutes. So please feel free to ask me any questions or stuff. I'll hang out here. And thanks for taking the time to join. I really appreciate it. I'd really appreciate it if you could fill out the feedback, and if you're interested in the bootcamp, sign up here. Mid next month probably, right? I'm a little bit sick, so I got to move it. So yeah, please feel. I'd really love some feedback on this. And yeah, I'm open to questions. I'll be here for 10 more minutes. Yeah. Okay, Daifan asked, this is not the bootcamp. No, this is not the bootcamp. This is just like a sample, if you will, with a lot of links. But the idea in the bootcamp is that you build up on smaller parts. You build up on start with Python, start with SQL, start with Unix, move to Spark, and then move to, after Spark, you move to data quality. And that's like the data transformation part of it, which probably will take a weekend. The next weekend would be data modeling and data flow. We'll go over the data flow, data modeling in depth, like pros and cons of SCD, slowly changing dimensions. How do you decide which one to use? How do you handle constantly changing upstream data? How do you communicate with upstream? How do you monitor upstream data? How do you do things like that? That will be the second weekend, right? So it's like data modeling, data flow, presentation. And let me see here, right? And how do you ingest data? How do you visualize data? How do you deploy it to the cloud with Terraform? What are the benefits of Terraform? How do you do CI/CD? How do you monitor, set up monitor and alerting systems? Things like that. And then the last weekend will be capstone and interview prep, right? So the idea is you have 3 weekends. That will be just intensive learning, but then you have to immediately start implementing data projects and getting referrals and doing interviews, right? You want to make sure you are practicing interviews and practicing interviews and practicing like getting referrals. So the 3 weekend will be learning, and then I will be available on chat. I'm deciding on like Slack or Discord or Campfire, and I'll be there for like 6 months to help you out, probably a year, help you out with that process, right? So that's what the bootcamp structure is. Yeah. Where's the form to fill up the bootcamp link? It's here on the Jupyter Notebook. It's also available on the description of the. Oh, I don't have it here, but it's in the bootcamp link, right? And if you're subscribed to my newsletter, you'll probably get it as well. Pratik asks, sorry, join late. I've signed up for the bootcamp. I just explained it, Pratik, but basically 3 parts: code and data transformation, data modeling, data flow, monitoring, deploying to cloud CI/CD. Third week would be capstone project and interview prep and next steps. Again, the course structure is supposed to be intensive 3 weekend, but then there will be a process you have to follow to land a job. It's not going to be easy, especially in this bootcamp, in this hiring market. You need to kind of constantly start practicing. I've seen a lot of people spend like 3 months, 4 months studying. In my opinion and in my experience, you want to kind of cram quickly and then start implementing, start building projects, start doing interviews. Yep. What are the prerequisites? The prerequisite is that you need to be a bit familiar with what coding is, right? Like you need to know variables, you need to know loops, you need to know what a class is, right? So those are the main things. Because we will cover Unix, we'll cover Python in detail, we'll cover SQL in detail. Yeah, those are the prerequisites, Charles. Abdul asks, when it comes to cloud, which cloud do you think I should focus on? I'm still learning AWS, but how can some be good with multi-cloud? It depends on your market, Abdul. Again, it goes back to this link that's in the kind of post. You need to research the job descriptions that you're looking for, right? So for example, in this, they don't say any AWS or anything because this is Netflix. You can, depending on your job description, they might say it. Again, I know that in the US, AWS is pretty big, but in India, there's a lot of Azure. So it depends on your market. I would just start with AWS because that's, in my opinion, the easiest. And then depending on your market, build with AWS and Azure. Most systems are similar with the basic components. It's just the operationality of them might be different. So for example, like AWS has managed Spark with EMR, whereas Databricks has its own managed Spark, obviously. Databricks is leagues ahead of AWS. So if the company you're looking for is using Databricks, you want to try Databricks instead of just AWS. So depends on the job description you're looking for. But in the bootcamp, it'll be mostly AWS and Databricks. Is this workshop the bootcamp? No, Sandeep. This is just like a small sample. Narendra, all the next steps that we haven't done. Yes, they are all part of the bootcamp. That's like 3 weekends, so yeah, I can cover that. Seawork, is there a cost? I haven't decided that yet. Keep an eye out. I'll probably send it sometime next week. How to troubleshoot Spark pipelines in production? That's a good question. Yeah, I do have something like that, but it's such a vague requirement, right? Like I do cover the common pipeline issues in productions, like you're not caching properly, you're checkpointing multiple times than needed, you're not organizing your data for efficient processing, things like that. So yeah, I will cover that. Any other questions? I think you didn't push this notebook that has the link. I didn't. Let me. So Fortnite Guruji says this notebook does not have the link. Let me see. I thought I did. Oh, it does have this. So you go here, click on it, it'll take you here. So go to the project, set up data project at IPython notebook, click on the sign up here, it'll take you here. Or you can, and please feel free to provide some feedback. It'll take you to like a type form. You don't have to give your email or anything, just some basic questions. So yeah, it's there. Are you covering requirements gathering? Yes, I am covering requirements gathering. You could also take a look at it on my blog. How to gather requirements for your data project. It goes in depth as well. Again, I will cover this as well as part of the bootcamp. It's mostly going to be AWS and Spark. I have DBT with Snowflake. So it'll be AWS for like the cloud infrastructure, DBT with SQL on Snowflake, and then for distributed systems, it's going to be Spark, and we will build a pipeline with probably Databricks. Yeah. Yes, it'll be covered as part of SQL. Yeah, so like what are seeds? How do you model the data similar to kind of this? And what are the caveats of it? How do you test data? How do you test macros? Things like that, Pratik. All right, 2 more minutes. If there are no questions, I can end it in the stream, I guess. Are we using the TPCH? In this example, yes, we are using TPCH data, yep. Are you asking about the bootcamp? We will use TPCH, but for the capstone project, you have to use a data of your choosing because TPCH is too easy. So in the bootcamp, we use TPCH for like data pipelines. For other systems like data collection, we use API systems like CoinCap and other Bitcoin APIs. We can use some AI APIs if we need, but mostly it's going to be TPCH data and CoinCap API data. Yep. When it comes to data ingestion, what tools are you used based on your? Typically, when people use AWS Snowflake, they just use Fivetran to ingest data automatically. But what happens is Fivetran, they set up with Fivetran. Fivetran gets expensive, and then they use their own or use like an open source things like Moltano or Airbyte or Stitch, things like that. But yeah, if you're going to larger companies, they just write their own. Now there is something called DLT that people are using. Most of the time, you want to be very clear on your requirements before choosing a tool because Fivetran is quite expensive. Like if you're ingesting like 100 million rows, they can charge you a lot, like 100,000, 50,000 US dollars a month. So you need to be very careful. It's 3 weekend Pratik, full day, so 8 times 6, it's 48, so 8 hours a day, Saturday, Sunday, for 3 weekends. I'll send all these details next week sometime. Any other questions? We are almost at time. Okay. Also, yes, Eric, it's full days. Unfortunately, you have to kind of do a lot, and doing it like 2 hours every day, it's not. It's going to take a long time. Yeah, and it's going to be mostly just me explaining and you guys coding along. It'll be similar to this. Yeah. Yes, it'll be recorded. But I think you should try to attend virtually as much as possible, because there'll be questions, but also there'll be like a chat support, so I'll be on chat. I'm deciding between Slack or Discord or Campfire, so I should have something on that soon. So yeah. Yep, that's right, Narendra. All right. Thanks everyone for joining. I really appreciate your time. Again, feel free to let me know if you have any questions on what we covered, or if you find any bugs, please open an issue here in the project. Go to issues and open it there. I'll try to put up a fix as soon as possible. I really appreciate it if you could leave some feedback. I'm always looking to kind of see what can be done better. Yeah. Yeah, thanks again, everyone. Have a good rest of your day. Bye-bye.